Hello. So in this segment, we are going to discuss the second method of solving equations when you have more than one equation. And this type of system is what we call solving systems by the elimination slash addition method. And sometimes certain teachers or certain books, they might call it solving a system by addition. They might call it elimination. It's the same thing. It's just what authors want to choose to describe the method, which is it's the same thing. All right. So in how to do this method, remember you're dealing with two equations. So we want to deal with that. Maybe we have two equations like this. We're going to think a little bit about abstractness to kind of get the theory down first before we go into the problems. I've always liked to have the theory behind it because it's kind of like your proof, the proof of it. So let's think about this. We have two equations. So remember, equations have to have the two equal signs. And so we're going to say that where A, B, C, and D are real numbers. Real numbers. So what we're going to do, according to what we call the elimination method, so the proof's in the pudding, so to speak. When you talk about elimination, you're talking about taking or deleting one of the variables to get the other one. So you're talking about deleting the other variable to get the other variable. So to keep it simple, that's kind of what it is. You're deleting or eliminating one of the variables up there to get the other one. Okay, and you will see where this fits in. I'm just keeping it simple for our sakes of demonstration. Okay, so what we're going to do with this, we have our two systems. We have one, we have two. The whole idea about this is to get rid of, so get rid of one variable. So we want to cancel it out. And what we're going to do to cancel it out, we're going to take one of these. We're going to take one of these and we are going to eliminate one of the variables by doing this. We are usually going to take this. Do you see how all these are positive? We're going to switch the whole equation, one of the equations only, to a negative one. So let me do this again. We're going to take either or. Let's say we want to eliminate x. So we're going to take this one, this whole thing, and see how these are positives? Well, if we added those, you won't get rid of them. You will have two a's. So what we're going to do, instead of adding, we're going to subtract and multiply this whole second equation by a negative number. And when you do that, you get negative ax minus by equals negative d. Take the one on top and move it over. You do not do anything to the top equation. So you're going to go ax by equals c. So all you did is moved it over. So you multiplied one equation by negative only. And guess what? Where it says addition, we're just going to add them now because that's what we're trying to do. We just eliminated technically we eliminated one of the variables, but we have both here. And sometimes this will happen. So if we add down, so we can add the x's, you get 0 x's now. Well, if you add the y's, you get 0 y's. But look what happens here. If you add these, remember these are real numbers, this is just going to be a number of some sort. But sometimes this will happen. You will get 0 equals a number. So 0 equals a number. Sometimes you will get that. That means there's no solution to this. So this means that there's no solution. And usually, sometimes that will happen. That's kind of saying that you're dealing with an a y and an x axes, and you're dealing with when they don't cross, they don't intersect to find a solution. Because that's kind of what the goal of this is, of a system, is you're trying to find, here's two equations, and when they intersect, you're supposed to find this solution to match both of these. And this doesn't happen. But this is the general idea of what we're trying to do. We are trying to eliminate one of the variables. And sometimes this can happen when you eliminate both the variables. So let's go through a couple problems to kind of see where this makes sense, because that's always nice to see more examples. Okay, try this one. So this is number 1. We got negative 2x plus 5y equals 10. We got 2x equals 5y plus 25. So there's our two equations. Now, in order to make this happen and to make this doable, a piece of advice is that you see the equal signs. I would line up the equal signs first. And sometimes this happens. So what I'm going to do is line them up. So to make them even. So I'm going to move this one over here. So I'm going to go 2x plus 5y equals 10. Okay. I have to, in order to do this, I would have to move this whole thing over. So it would be like 2x 5y plus 20, plus 25. It would be something like this to line up the parentheses. This looks terrible because the variables are not lined up. So what I'm going to do is take that away and line up all the variables. So the 2x, I'm going to line up with 2x. Well, look where the equal sign is. Well, look where the y is. So the y is on this side of the equation. So what I'm going to do to make it on the same side as the x, I'm going to just take this one and move it over there. Do you remember when we take something from the other side and move it to the other part, we want to subtract it or add it. But remember, we want to balance it out. So if I subtract 5y here of the equal sign, I got to make sure I subtract it over here. So this is going to be 5y equals now 25. All I did is moved this over there to make all the equations line up. Okay, now look at the problem. Remember, we want to eliminate one of the variables. Well, look at this. We have different digits here. We got different digits here. So this is kind of like the one I just showed you. And what happens, we're going to add this because when we add these two, we get 0. When we add these two, we get 0. And if we add these, we get, what, 535. So this one, there's no solution to it. There's no solution. They do not cross. So this is a typical, sometimes you find this. But I had to manipulate it a little bit to kind of get things lined up. And I want to make sure I do that to make it a little bit easier on me. Okay, so let's do another one here. Number 2, let's do one that actually works. So let's do x plus y equals 3, and let's do 6x minus 5y equals 20. Okay. This is pretty good to have it all lined up for us. We don't have to do any manipulation. All the equals are lined up, all the y's are lined up, and all the x's are lined up. Good. So this is a typical one you're going to see majority of the time, but it's not always perfect like that. You're going to have to do a little bit of manipulation. Okay, so here's our idea. We want to get one of the variables to be eliminated. That's our goal. And here, if we just go ahead and add these together, we're not going to eliminate. If we just add these together, let's just add them together, see what happens. We get 7x. If we add these, we get what? Negative 4y, and we get 23. Now, my suggestion is that we got to do something different, because this is not going to work. Because how do you go by here? How do you go by here, and what do? You have two different equations here. And you can't just say, well, I can graph this. If you graph this, it won't work. It's a typical way that you can say that, oh, okay, if I graph this line, if I solve for y, I get my slope and my y-intercept. You can't really go into that because you're creating a math that is not working. So we want to take this away and do something else. So I'm going to pick, so number 1, I'm going to pick a variable to eliminate. And 2, I'm going to multiply the whole equation by a negative or a positive. By a negative or positive to get rid of the variable. And number 3, we are going to solve. We're going to add both equations. So that's kind of what you're doing. You're going to add both equations. All right. So step 1, pick a variable. Well, let's see. I got negative here already and a positive here. Well, why don't I take this one right here? Since there's a negative 5y and I got a positive y, why don't I multiply this by 5? And if you multiply that whole thing by 5, look what happens. 5 times x is 5x. 5 times 5y. 5 times 15, 3 is 15. Did I do anything to this one right here? Did I do anything to it? No. Just bring it down. Make sure you match it up. I did not touch this one at all. I touched this one. So, now, I picked a variable to eliminate. I want to eliminate y. Multiply the whole equation by a negative or a positive. Well, in this case, this was a positive. 5 is fine. Add both equations. So, like this, add. That's why addition comes up in the title. So add them up. Well, we got 6x plus 5x is 11x. Oops. We got, oh, look at this. 5y minus that is 0. That's what you want. You want to eliminate one of the variables. 15 plus 20 is going to be, let's see, that's 35. All right? Okay. We want to, now, number 4, we want to solve for that. We want to solve for that variable. Well, there's your variable. This is 11x equals 35. So what we're going to do is that we are going to solve by dividing. X equals 11 goes into 35. Well, 11 times 3 is 33. So this is 3. Oh, that's going to be 33. It's going to be 3 2 over 11. So 3 to 2/3, which is going to be about 35. Because 11 times 3 is 33, plus 2 is 35 over 11. Cool. That's for x. Well, we have to get y. So now this is step 5. We want to plug in the solved variable into the original equations. So we want to put this into one of the originals upstairs. And when I say originals, that means the ones that were just the same when we started. We didn't manipulate them. They're the originals. So since that the first one is very easy to put a number in for x and then solve for y, I'm going to do it that way. So I'm going to plug this for there and then solve for y. Okay, so I'm going to plug that in, so I can use either or. I'm probably going to use the improper fraction because it's a lot easier when I just take 3 away. Well, I don't have to do a lot of manipulation. That's okay. So let's do 35 over 11 plus y equals 3. All I'm doing is plugging this, this, which is the same thing, into the first one. So, and then solve for y. So I'm going to go negative 35 over 11 over on this side. And then go ahead and go y equals, I have to subtract this. So this is going to be 35 over 11 plus 3 over 1. Get a common denominator. So if you don't like fractions, there's a video that I did. It's called the butterfly method on my channel. That might help you. If you don't like that method, you can always do it the other way. I'm just going to do the butterfly because it's what I've taught. So I'm going to take this and multiply it, which gives me negative 35. I'm going to take this and multiply it, which gives me plus 33. Take this, the bottom, times it by 11 because 11 times 1. Like I said, my video will explain how to do this, so go to it if you're not too sure. And then just go ahead and add the top. You get negative 2 over 11. And that's your y. Okay. There's your 2 answers. If you were to graph these, they would, on an x and y axes, they would intersect somewhere about there on the bottom. The reason I know that because look at your x's. X is 3 over on the x's. Look how many y's. Remember the y's, they go down. This one's negative, so it's going to go down. So it's going to go down somewhere down there. That's where these two lines cross. This, when they cross, this is what you call your solution. That's your solution to your equation when they cross. That's what you're looking for by this method. All right. Let's do a couple more. Number 3. Try this one. Okay, if we try this one, remember our first thing is to pick a variable. I'm going to look at my 2 here. So this is number 1, this is number 2 equation. Number 1 and 2, I can eliminate x right now. Because look what x has. X has the same number on it. The 5x. One has a positive, one has a negative. Well, right there tells me if I add these right now, I get rid of a variable. And that's what I'm going to do. I'm not going to multiply or divide. I'm multiply by anything because I don't need to. If I do that, I'm just making it worse. If you're thinking, well, why can't I just solve for y? Well, look at what you have to do in order to solve for y. I am not going to hold your hand on that. You could solve for y if you wanted to, but I'm not going to do that because you're going to have to, what you would have to do, I mean, something you could do if you wanted to solve for y. I don't know why you would do this, but if you want to solve for y, you could take the second equation and multiply by negative 2. That would work. You could multiply that by negative 2, which if you multiplied this whole bottom by negative 2, you get 10x minus 4y equals negative 60. Of course, then you can solve for, then you could eliminate the y's. But I wouldn't do that. That just makes it longer than I don't really need it. So you could do it this way, but I'm not. I'm just going to say, well, add them. And that goes to 0. Add these. Well, that's just going to be 4 plus 2 is 6y. And then you got 30. Solve for y. Divide by 6, divide by 6, y equals what, 5? There's your equation. Remember, you have to get, there's y, there's an x up there. Go back to the originals. Well, the originals, we didn't manipulate any of these. We can just pick any one we want. I'm just gonna pick number. I'll pick number 1 because it's a little bit more simpler, I think. I don't know, you can pick 2 if you want. Doesn't make a difference. I'm gonna pick 1, and I'm gonna put this in. So here's number 1: 5x plus 4 times 5 equals 0. All I did is plug this into that one. So I get 5x plus 20 equals 0. Solve for x. So minus 20, got 5x equals minus 20. Divide, x equals, what's that? 5 goes into 20 4 times, but we have a negative on the top. So that's negative 4. And there's your 2 equations. Now, since these are pretty straightforward and nice, easy numbers, why don't I prove it to you and see if they work. Because this one's pretty straightforward. And you can do these on all of them. So what I'm going to do, my solution, remember, is x comma y. My solution is -4 comma 5. There's my solution if I were to graph these. This is where the point of intersection would meet. Let's see if it holds true. So what I'm going to do, look at number 1. Plug these two values in there. So I have 5 times -4 plus 4 times y, which is 5 equals 0. Well, that's -20 plus 20 equals 0. 0 equals 0. You're done. If you do it to the second one, it also works as well. So let's see, the second one is -5 times -4 plus 2 times 5 equals 30. Negative times a negative is a positive. 2 times 5 is 10 equals 30. Well, 30 equals 30. Done. So they both have to work. That's the whole idea of this. You're trying to get both of them to work. If you were to graph these, if you were to took something like this is, if you were to taken this and you would have put it in that y equals mx plus b form and graphed it, you would find out that this is what they call the intersection. This is what they call the intersection. This is where they both cross, which gives you a solution. A way that you could look at this, if you were dealing with revenue and expenses, revenue and expenses, and you were looking at a graph of, let's say, you had some money and you took out a loan. And in statistics, they call it a break-even point. So let's say that you had your X and your Y, and your revenue is how much you're getting every day. Your expenses, well, your expenses is what you're going to, maybe you're trying to make less. So let's say I make computers, or I make a product that cost me $5 to make. Well, that $5, if it costs you $5 to make, eventually that's your $5 line. And where they cross in your system, so let's say your revenue, which is your R, is an equation of some sort. And your expenses, which let's just call it E, is another equation of money. And where they cross is where you hopefully break even. And if you go ahead of the break-even point, that's where you make the money. That's where you make profit. Another way you can look at this: what if you took out a loan for like took out a loan and the loan cost you $10,000? Well, that's way up here, and $10,000 over a time might be for 5 years. Well, that's going to be linear because you have to pay it back. And your revenue, well, let's say that your revenue, you're increasing the money, but it has expenses too, so you can be dealing with expenses, and somewhere along the line they're going to cross, and that's where you find out what's the time or the date that I can actually pay off this loan and get the revenue. Okay, I will give you a practice one, and I think we're going to be good with this. So what about this one here? Let's do, what is this, number 4? Let's do 12x minus 4y equals 4. let's do negative 3x plus y equals negative 1. So here's your first equation, here's your second equation. Pause the video right now and try this. Okay, so I hope that you pause this video and you try this, because this is something that you have to do. So let's see what you got. I hope that you said that, well, I need to get rid of one variable, so I'm going to get rid of the y's, because all I have to do with the second equation is times it by 4. So if I times it by 4, the first equation I didn't touch, so I'm just going to rewrite it. The first equation I did not touch. The second equation, 4 times 3 is negative 12x. 4 times y is going to be, let's see, positive 4y equals negative 4. Add, and look what happens again. Oh, the whole thing is 0. So 0 equals 0, which is actually a true statement, but this doesn't work. There's no solution to this. Okay. Like I said, there's lots of things you could do. I can sit up here all day and just throw equations at you. But I think that you need to dive into more, and you need experience of canceling one out. Best idea is look online. Sometimes there's elimination method. Look it up. Go to process of elimination. They would give you some practice problems. But rewatch this video, go through my explanations, try them before I do them, because you have the solutions, and just keep practicing. Really, just keep getting these skills going. Okay, so hopefully this is good. I'll see you in the next one.